When we talk about quantum computing, it's a completely different game.
Quantum computing will enable us to solve problems that currently take longer than the lifetime of the universe in seconds, hours, or days.
We completely reconceive the space in which we do computation.
Quantum computing is like going from crawling to going to a different planet. It's different.
It's only natural that we would want to use the world's most powerful device to combat the world's most challenging problems.
We could attack global warming.
Security.
What are the boundaries of machine learning?
Fighting diseases. The possibilities of quantum computers are endless. Microsoft has the best and the brightest working on this problem.
It's really happening. Progress is very fast, and we're building a quantum computer.
What the world wants to know is what happens when we turn the machine on.
What problems will be solvable with a computer that computes in a billion parallel universes at the same time?
Is one of these really exciting things just out of our reach at the moment. It's processing power where the computer system doesn't see a piece of information as a 0 or a 1. It sees it as both at the same time. And that speed of processing power really is going to be revolutionary. It gets me excited and proud that Microsoft is working on future stuff like this. But you know what? In 1962, we all got excited about living life like the Jetsons. And I'm still wondering where Rosie is to clean my house. And so we tend to overestimate how quickly we're going to get to that future and what it looks like. The reality is that a lot of organizations are still dealing with this. Okay? Even if you've put stuff in the cloud, you've still got a room that hopefully looks a little tidier than this one somewhere in your organization. And so we're kind of in this mode right now where we're operating at two different speeds. We have customers that come up with statements like this. We're a business of millennials, and with any tech project we look at, if it has to be installed, we cross it off our list. This is an organization of accountants, one of the more traditional risk-adverse industries that you can find. And so that's how they're looking at technology. On the flip side, Microsoft is having to invest funds and resources into marketing campaigns on things like this, educating our customers that some of our products are going end of life, including Windows Server 2008, which is an 11-year-old product that still just works. And so we're investing time and resources into helping people shift off that platform and modernizing their operations. It's a bit of a fight to do both. Our marketing department will stand up and talk to you about the benefits of having a modern workplace and all of the great things that you can do with data and AI. And we've seen some of those stories today. The benefits of those in terms of empowering our employees and optimizing our operations. And that makes it look so easy. But what we don't talk so much about is this very important line that kind of stands in between the new tech that we're putting in and the benefits that we're going to get from using it. There's a fair bit of sort of complexity and work in that little grey line. What does that mean for the people who have either been in the industry for a long time or they've got the skills to operate the workloads that we've been operating for so long? The people that are at the coalface keeping everything running. Are we going to see them out of a job? Are they going to have to reskill? What does their world look like? And so when it boils down to it, IT operations still does, and I think always will, boil down to three main things. It's about provisioning systems. It's about putting in new things. It's about managing those systems and making sure that they run, that they fulfill our needs, and that they're configured correctly. and it's about firefighting and reacting to problems. Now, that is true when I started in tech over 20 years ago, and I don't think that those three things are going to change. How we do them is changing, and what the details of those look like is changing. So what does this mean for the cloud? If we're putting everything into the cloud, surely we've got now a bunch of server admins that are out of a job, right? Or maybe it is just somebody else's computer that we're using, and we've still got some roles in here. This is what we're figuring out. When I started in tech, this was how we provisioned a new PC. So we formatted the C drive with the /S, very important, that makes the system bootable so it will actually start up. And then we did an X copy of files from somewhere else onto this new system, fired it up, hey presto, here is your 286 or 386 DOS PC, all your applications on it, and you are off and running. It was really easy. Now with the cloud, we've kind of come full circle a little bit, because we can get to a point now with code where firing up a new server in the cloud as a virtual machine looks something like this. This is PowerShell code for starting up a new virtual machine and all the configuration that I want it to have. So same but different, kind of similar, but a new language to learn. But of course, it's not just hardware and licenses anymore that we're provisioning. It's things like cloud virtual machines, we're looking at infrastructure and configuration as code, right through to containers, serverless and IoT devices. So we've got a whole new bunch of stuff that we need to start provisioning and learning how to do all of this, or figuring out where our role is in the provisioning of some of this stuff, if it's out of our hands, if it's developers that are building serverless stuff, or some other project team that's rolling out IoT devices. How does that kind of fit into the work that we do? So what we're seeing is that our sysadmins are starting to need skills in these kind of areas. GitHub. Now, I am not an application developer. I do not code at all. It is not my thing. But I've had to learn to use and love GitHub, because GitHub is a really great place for finding PowerShell scripts and for finding a whole bunch of new commands and capabilities that Microsoft release in their GitHub repositories before they make it into our Azure portal or into our other products. We've got automation with pipelines and GitHub Actions just released, provisioning policies, PowerShell scripting, all of these things that are now skills that IT operations people need to know. But I don't want to lose sight of the fundamental underpinning knowledge of how things hang together and what we're building. When I started in tech on a project to roll out some new servers to a bank, one of the project teams sat me down and taught me how TCP/IP works. All right? It's not the kind of thing we tend to do anymore with new people into our field, is teach them that underpinning, this is how stuff actually works, to give them a better understanding, to help their troubleshooting skills when things don't work anymore. High cost control. I love this topic. I have great conversations about this. How much is it going to cost? That does have some overlap into the IT operations space. We need to know how to estimate that cost correctly when we're looking at you putting systems in the cloud. We need to figure out how to protect our organisation from cost blowouts with the consumption and the usage of those systems. And then we need to review the spend to make sure that it's what we expected, and if it's not, is it because we have a bigger context of a lot more business benefit and increased demand and usage from our customers? It's not always about cost minimization. So these kind of conversations are kind of dropping into the IT ops space as well to justify what you're using and how much you're spending and why it's relevant to your organisation. And that's relevant whether it's infrastructure as a service, platform as a service, or software as a service workloads that you're using in the cloud. It's creeping into the IT ops space as something we need to be doing. And that's before we've even started to talk about all the other stuff that is coming on our radar that we need to start provisioning, whether it's bots, big data, digital twins, serverless with functions. It's a busy time to be in IT operations in terms of change. It kind of always has been. Our industry has never stood still, but that pace of change is going slightly crazy, as it does. From a management perspective, a lot of these terms are familiar if you're used to operating IT workloads. What does capacity planning look like in the cloud? Are we sizing things effectively? And where does the cost conversation come into that? Have we got the ability to scale up when we need it, or are we overestimating and therefore not utilising as much as we could be doing? What about our performance monitoring? Now that we don't hold the servers in our own data centres anymore, what are we monitoring? What is relevant outside of just maybe CPU usage and RAM utilisation? Are we taking into account things like latency and application performance? What does that sort of bigger picture look like? Reliability, availability, and redundancy are all different conversations now the clouds come into play as well. So are we using the cloud as a source for redundancy and failover from on-premises systems? Are we building in redundancy from one cloud data centre region to another cloud data centre region? And what does that look like in terms of our architecture? Backup and disaster recovery, I promise you, is something that we call a shared responsibility. So as a cloud provider, we have a responsibility to build as much resiliency as we can into our data center infrastructure that you use. But if something happens in your application and your data gets corrupted, that's not our problem. So you still need to think about things like backing up your information, recovering from a disaster where your organisation has had ransomware come through it or somebody's deleted something that they shouldn't have, okay? Those kind of things are still relevant even when you're operating in somebody else's data centre. And what about system updates? I love one of the sessions, the earlier session about security that talked about patching. Of course, if you're running infrastructure as a service, if you're putting virtual machines into the cloud where you are managing the operating system, you still have to manage the patches on those. And you may now also be doing that in the cloud as well as for your on-premises machines. So you're going to need a system that gives you a full view of all of those assets when you patch them. And then you've got to figure out what happens when the cloud provider goes and does some updates to their systems, and how does that impact you? Now, we do try to minimise any impact of you. There's a lot of changes that happen in our data centres that you don't even see because we have the resiliency and the failover, but it's our job to communicate to you when we do have plans that may impact the availability of your workloads. The cool thing about it though is we are starting to see some of the technology come into the work that our IT ops people do. This is one of my favourites that's recently been announced, which is called dynamic thresholds for monitoring. So if you want to set some performance monitoring on a system, you might turn around and say, okay, tell me if the CPU usage for this system drops below 20% or peaks above 80%. So I'm quite happy for it to bounce around in between those two thresholds, but I want to know if it's gone higher or lower. Chances are, system's really stressed, I'm going to be having performance issues from my users, or if it's not even getting to 20%, then I might have some other failure where that system's actually not being accessed, it's not being hit. I've got to figure out why it's not performing as well as it should. With dynamic thresholds, the AI and the machine learning will actually have a look at the performance and analyse the system as it runs, and it will dynamically set what is normal for that system. So you don't have to work out what those number thresholds are. And it will adjust and learn as that system performs over time, but it can also take into account when that system is normally quiet. So if that system only runs 9 to 5, it doesn't run outside of business hours, that's fine. You don't want an alert going off because nobody's hitting the system at 11 o'clock at night if, guess what, nobody's using the system at 11 o'clock at night. And it also takes into account weekends and things like that. So it starts to learn what's normal for that particular system, sets the thresholds dynamically, and then we don't need to worry about managing those kind of CPU numbers. We just need to worry about the alerts when we start to get them. And then we've got things like IoT Central. And IoT Central, they're new management tools that we're going to have to learn and get our heads around. This one's come out of a need for managing IoT devices. So a centralised dashboard for figuring out, are those devices healthy? Are they secure? What telemetry are we getting from them? Not so much the data management side, but the actual device management and health side of those IoT devices as well. New skills to learn for IT ops when we've got other things to be looking after. And that's before we've even started talking about these things called ephemeral apps. Ephemeral apps are really interesting because it's kind of like, when is an app not an app? And an app is kind of not an app when it's made up of a bunch of different things. So it's a little bit more piecemeal than what you'd think of building a traditional piece of application. But we're threading these together with things like a sensor firing and sending some data through to a cognitive service, and a cognitive service detecting an issue in the data, which is then pinging off some automation or some notifications. So it is an application in a system itself, but it's made up of a collection of different things. So now we've got a whole bunch of other stuff to be provisioning and monitoring. From a management perspective, it's not so much now about managing the operating system or managing the life cycle of a hard disk. We're moving into this kind of territory. We're responsible for managing the access that people have into systems and into data. We're responsible for managing the information inside those systems. Where can that information go? More than who can access that information, especially depending on the level of sensitivity of what we're storing. And then how are we making sure that our systems are configured the way we want them to be and configured in a way that makes them legally compliant in the industries that we're working in? And how are we monitoring the security of our systems and our data? Identity is the new control plane. When I started in tech, security was so much easier. You had to swipe card in, sit at a corporate PC, log in, and that data was protected from the internet by our corporate firewalls. That was the only place you could access it. Now people want to access everything from anywhere at any time. And the most important thing standing in the way of somebody else in your data is that identity, it's the credentials, it's the logging in process. And we see that with phishing attempts all the time. We're moving beyond passwords, and we're going to a world now where you don't need to remember that multi-digit character thing that someone might grab with a keylogger, to looking at extending the idea of multi-factor authentication into, let's just get rid of passwords altogether and use MFA tools so that the system will prompt with a single-use code, and my multi-factor authentication that I've signed in with my biometrics using Face ID, so I've got access into the system, now asks me to choose which of these codes the application is displaying, and that will do my authentication and my authorization. Makes it a lot harder for somebody to phish and get your password. If they try and log in, they now also need your phone and authenticating onto your phone and getting this challenge right in the application logging, making it harder for the bad guys, a lot easier for the good guys. And I love what we're doing in this space in terms of being able to look at risky behaviour. So it's about plugging in the information when an event happens about who was the user, what device were they using to access the information, where are they located, and what are they trying to access. By reading all those signals, we can then come up with a risk score and go, okay, if this person doesn't have a lot of access into the organisation, they're accessing a fairly standard documentation app, they're using it from one of our corporate devices that's got our software management on it, and they're actually doing it from inside our corporate LAN, that's going to be a much less riskier score than if it's the CFO's credentials popping up at a shared internet cafe in Nigeria. Okay, so now we've got the data about what's happening as that person is getting the access. What controls are we putting in place? What corporate policies do we have that we can then enforce in real time to say, you know what, I'm happy to allow them straight in there on the corporate network. I think this looks a bit dodgy. I think I might ask them for a multi-factor authentication code, or this looks really risky. I'm just going to block it completely. And one of the cool examples of that deny access one is something called impossible travel. So with impossible travel, if I was to log on to my corporate computer here in Christchurch, and then 3 minutes later, there was a login from my device in Auckland, it would block that login in Auckland because it knows it would take me longer than 3 minutes to travel from Christchurch to Auckland. So that's the kind of stuff that we're doing with machine learning and AI to help improve security, to help handle this, I need to log in for anywhere and still be productive. And then from an information protection side, we're looking at being able to detect, classify and protect information. This comes down to things like detecting if someone in your organisation is sending an email that's got a credit card number in it. You might want to put a corporate policy to say, email is not at all a secure method of transmission for credit card numbers. It's not PCI compliant. It's really easy to sniff email packets and get credit card details. It's not something you really want to be doing. So we can actually put corporate policies in place that go, hey, it's kind of the Clippy, of 2019. I see you are sending an email with a credit card number in it. Let's either fire up a tooltip saying, let's not do that. You might want to revise it. There's a feature about that, about attaching files too. I see you've forgotten to attach something, which is really handy. But at a corporate level, we can block that from actually being able to be sent completely. So this is the kind of information classification and detection now that's important. And we've talked about moving to this fast speed where developers in the business wants to move fast. We've got competitors chasing at our heels. We've got all this new tech to play with. And yet, from an operations perspective, there is still value in making sure things are compliant and they are secure and things are configured correctly. So let's get rid of, to some extent, ye old change control meeting where you had to fill in your 5 pages that told me what you were changing, when you were changing it, what was going to be impacted, how long stuff was going to be done for. And let's build some policies into the Cloud engine that can automatically approve or decline some of these changes. And we can now monitor the policy bit and let the engine do the real-time enforcement. Let's get out of the way of slowing things down. And that comes into things like DevOps as well, where we're working with software developers where it's not the old school, they finish packaging everything, they give me the package and then I go and deploy it to all the workstations. They want to iterate fast and release stuff as soon as possible in little bits. But I still want to make sure that within that policy, within that process, there is this policy enforcement. There are some things that I'm not going to let them do and deploy in my environment to keep everything safe. Azure Policy is really good for that in the cloud because not only for our cloud resources, but for your on-premises resources, you can get this dashboard view where you can actually see the compliance across your environment of which systems are compliant with those policies and which aren't, which is really great for preventing configuration drift. So configuration drift comes from when we built this system, it was set up correctly, and someone's come in and changed something. That happens sometimes. So this can tell us that there are some policies and some systems that are not compliant because there are some changes that have been made. It's about giving us easy access to see that across the view of all of our resources. And then from a security perspective, how are we bringing in all these different things that we need to make sure that are secure so that we can keep an eye on them? And I don't want to turn this into the Microsoft pitch fest, but we're addressing it with things like Azure Sentinel, which is giving you this, I call it my single glass of pain, because it tells me where all the problems are in the organisation. But it's about pulling all of these metrics into one place and then using machine learning and AI to analyse these signals and, more importantly, to reduce our alert fatigue. I mean, my life used to be going through event logs on servers. And if you've ever been in an event log in a server and you've seen the screeds of red that are in there, some problems are actually just normal. And some things just happen. And weeding out what's important from what's not important is a lot of the job. And so this kind of stuff is about doing this threat detection and analysis based on what's good and what's bad. Not only telemetry from you, but telemetry that we get from all of our systems that improve those engines so that we can improve your monitoring and alerting. And then finally, we've got reacting when things go wrong. Alertpalooza, I've just talked about reducing some of that noise and that fatigue. How are we building systems to fix themselves? How are we self-healing our systems and our applications? What are we doing for business continuity? If the cloud provider goes down, how does your business survive? Okay, that is still a business problem. As much as we will tell you that we have a 99.9% SLA, depending on what level of version of our products that you buy, the impact is still on your business. Okay, don't think you don't need to worry about this kind of stuff. Same with data and disaster recovery, and a security breach response still comes down to your organisation having to deal with it if your data gets broken into. So we're looking at things like using the cloud as a way to be able to improve disaster recovery for on-premises workloads. Have that as an option as a failover site, fail up into the cloud when you need it. So you're not paying for the cloud when you're not using it, apart from maybe a little bit of storage. But you can pay for those workloads to be up and running really quickly if you do have a site go down. And then site-to-site recovery as well from one cloud region to another. It's all about getting your head around this pets versus cattle argument, where you know your pets by name and you love them individually and you know each of them. When I log on to Facebook, I do not know the name of the server that I'm hitting. And that's where we're going to with things like serverless and containers and even some of our cloud workloads with our scale sets. You will not necessarily know the name of that particular server. I can't walk into an Azure data center and tell you which piece of hardware is yours. It doesn't work like that. And when one of those pieces of hardware gets sick, we get rid of it and we bring in another piece of hardware and you don't know any different. And so that's how the cloud works. And so troubleshooting in that environment, what do we do when we lose a container? We usually make sure that systems are built so that another one spins up. What happens if a function doesn't function? How do we troubleshoot that? What happens if a dependency fails? So the application's fine, but it's something like DNS, it's always DNS that we've had an issue with. And so we're starting to see finally what the new skills for a sysadmin look like. So here's a recent job example. AWS and or Azure hybrid cloud. So I tend to think of hybrid as being I still have some systems on-prem and I also have some systems in the cloud. Multi-cloud's a different story if you've got workloads in 2 different providers. These are the kind of skills that our new sysadmins need to have. Understanding cloud security concepts and how they differ in terms of network security groups and all of these kind of cloud security analogies. PowerShell and other relevant scripting languages. So I must admit, my earlier days of tech, I did dabble with Kix32 scripts. We did have a little bit of scripting and automation in there, but now it's becoming even more relevant. Automated deployment using templates. YAML and JSON. Like I said, I'm not a coder, but things like YAML and JSON and custo queries are now becoming a thing that I need to learn because they make my job easier and they give me access to more powerful tools as well. Automation via scripts again, and I just love the fact that this job actually said Windows Server System Administration in it as well. And I'm like, the sysadmins right now aren't necessarily purely cloud admins. And if they are cloud admins, they may still be running Windows Server workloads in those clouds. So you do really need to have a mix of all of those skills. It has been said that the factory of the future will only have 2 employees, a man and a dog. The man will be there to feed the dog, and the dog will be there to stop the man from touching the equipment. Maybe that's where we'll get to with the cloud. Maybe even quantum computing, we'll end up with something like this, I don't know. But what I can tell you is we're not going to get to this as quickly as we think. Thank you.
Thank you, Sonia. We have time for one question only, and the highest rated question is, do you have any metrics on the uptake of multi-factor authentication for the Microsoft stack? Is the use growing, or do we need to do a better job of stressing the importance of this?
Okay. I don't have any stats off the top of my head. The usage of it is absolutely growing. We want to get the word out there that it is your best possible line of defense right now, especially in terms of phishing and hacking attempts. Please MFA all the things. What we are doing in the background to help making it easier is something in alignment with that conditional access policies. So we're putting stuff in place so that you don't get bugged all the time for that extra authentication code. If you are sitting on the corporate LAN on one of the corporate systems, you don't want to have to get out your phone and do the 2FA. So we're seeing more of a merge of that kind of analysis of when MFA is needed and when it's not, which will make a better end user experience rather than it just be a blanket approach of I've got to turn it on and every time I log into the damn system I need to put in the code. So that's where we're going to help make it better, to help up-level the adoption of it. But please, yeah, if you haven't, just MFA all the things.
Awesome. I want to say thank you again to Sonia. Big round of applause, please.